Okay, so I will start the equation maybe to go to sigma fx, and then I will go to sigma fy, and then the last one sigma moment. So let's say I'll take this direction as positive. Sigma fx equal to m a in x direction. So we resolve the a into x and y direction. Okay. The m is mass. We don't have direction for mass, but the acceleration we have the direction. Sigma f, force we have the direction. Okay. So take all the force in this direction. So here is directly P in x, A and B is in y direction. MA is already in x direction, so you don't have to resolve. But the last one, MG, we have MG downwards, so you have to resolve one into x and one into y. So you resolve here, you have 30 degree, and here also should be also 30 degree. So I've resolved that one into x, so here will be MG sine 30. No, here will be mg cos 30. We take this angle 30, so it will be cos. The other one will be mg sine. Okay, mg cos 30 and mg sine 30. Okay, so we go to this equation sigma fx. So put all the force in x direction. So the first one we have the P positive, that direction. This one is y, this one is y, this one is y, and we have this one. So opposite direction, so negative mg, m is 10, g, if nothing said, you will use 9.81. Okay, it is negative because opposite direction. So sine 30 equal to, okay, this is from free body diagram. So equal, the other part will be from kinetic diagram. So kinetic diagram we have MA, which is directly in x direction. So M times A. M is 10, A is 2. Okay, so you have sigma F equal to MA. So calculate this one, you should have P equal to, okay, so just calculate that one. You will have directly the value of P. Value of P, 10 times 2, 20. Minus, put the other way will be plus 10, and then 9.81, and then we have sine 30. So here we should have 69.05 Newton. The value of P. So we have covered the first question. What is the value of P? We have 69.05 Newton. Okay, so we go to the second equation. We can use sigma Fy. Okay, but if I use sigma Fy, notice that I will have two unknown, because I have A and I have B. So two unknown. Okay, so maybe it is better for me to directly use the third equation, which is sigma moment first, so I can have the answer. Okay, for sigma moment, okay, sigma moment normally we will solve. We choose the point that we can eliminate one of the unknown. Now this is already known, which is 96.05. The only unknown is A and B. So we can take sigma moment at any point actually, but to make easier, you can directly take sigma moment at point A or point B. Okay, if you take at point G, for example, you will have these two unknown, and then you go to the sigma Fy. You have two equations you can solve also, but it is easier if you take, for example, if I take at point A, I will have B as the answer. If I take the point B, I will have A as the answer. So choose one of it. So let's say here I will take clockwise positive sigma moment at point A. Okay, sigma moment at point A. So sigma moment at point A. Okay, so here I will have this one. Actually, I will put here. This is the first one and the second force. Okay, I'll transfer here because it is actually at the G. So sigma moment at A, so that one will be 0. A, B, so B, and the distance is towards here. Distance is 4 meter. And the direction, we said that clockwise positive. So here, if I put a pin here and I pull this direction, the component will move counterclockwise. So here will be negative. Okay, okay. So P is 69.05. 69.05, and then what we'll have is, I put a pin here, pull this direction, it will go clockwise, so plus, and the distance is from here to here is, this is 2, so we have half of it, 1, okay, so BP, and we still have 2, which is this one cos and this one sine. Okay, so this one, if I put it here, pin and push downwards, so it will be positive mg. M is 10, 9.81 cos 30, and the distance will be here as 4, so you should have 2. Pin at here, pull this direction, so we go counterclockwise. So the last one is negative 10, 9.81 sine 30, and the distance is, this is 2, so we have 1. Okay, so this is from free body diagram. We go to kinetic diagram. Okay, kinetic diagram, so you know that moment is force times the distance. So MA is force. So MA, force. You want to take the moment at this point. So equal to, this is force, M times A. M is what? M is 10. A is 2. Okay, so you take, put pin here, pull this direction, so you turn clockwise, so it will be positive. Okay, and the distance is to this point. Here you will have 2, so 1. Okay, 1. Okay, so you have this equation, sigma F, sigma moment at point A. So from here, you can see that you only have one unknown, which is B. Okay, so you can calculate, you can have the value of B equal to. Okay, so calculate that one, you will have the value of B. Okay, so B, maybe I just put the B, the other part, so this one will be negative, other is will be positive. Okay, so 69.05 plus 10, 9.81, this is cos 30, and this is 2, equal to minus 10, 9.81, and then sine 30, and then 1 equal to minus 10 times 2, so minus 20 equal to, okay, and then divided by 4. Divided by 4, so you have this one, B equal to 42.48 Newton. Okay, notice that if you draw the correct free body diagram, which is for normal force, it is always towards the component. So your calculation cannot be, B and A cannot be negative result. Okay, your calculation for B and A must always be a positive, because if you draw the correct free body diagram. Okay, so for the normal force like A and B, if you get a negative result, you should check your calculation, something wrong somewhere. Okay, so the last one will be sigma Fy. So we can put it here, sigma Fy. Last part, this is this direction, positive. Sigma Fy equal to M A in Y direction. Okay, so take all the force in Y direction, which is now the first one we have A, we have the B, plus 42.48, and then B is in X direction, we have here downwards, so minus M is 10, G 9.81, cos 30, okay, so direction downward, mg cos theta, so you have this one, so 1, 2, 3, so 1, 2 and 3 equal to MA, this one is already in X direction, so MA, Y direction is equal to 0, there's no A in Y direction, okay. Okay, so this one equal to 0. You will notice that you have one unknown here, which is A. So calculate that one. You will have put the other part. So we have 10 times 9.81 times cos 30. So you have this one positive minus 42.48 equal to, okay, okay. So logically you have same answer as A and B, because you have two roller which is put on the end side of this component. So the force is divided equally for A and B, and also P is right in the middle. Okay, so you have here